Okay. So, welcome everyone. Our topic today is the OpenQA fully automated testing system we developed for OpenSUSE, but is also usable for a lot of other operating systems. This is a short overview about, we'll talk about what is, why we need it, what it's good for, and the most interesting part, how it works, comes here. So, it's fully automated, so it tests all the time without me doing anything. I can be a week on vacation and still have 100 test runs complete without me. And why we need it is because our distributions look like this. It's not one floppy disk anymore with one kernel and one bash or simple user space, but we have big KDE with libraries and dbus complex interaction things. And since we our users could face crashes and get lost and change to other distributions which have less crashes, and so we want to avoid it, and we do this by automating the tests so that we catch the most obvious bugs in our software. And we can use it for quite a number of different cases. We can install whole operating systems, run applications on top of it, upgrade from older versions of distribution, and test for old or new bugs in the software. And the basic principle how we do it is we do the same as a normal user would do, which is take a virtual machine and put a hard disk in, or maybe 4 hard disks, so that you can test RAID 6 or RAID 10, and then you put a virtual CD drive in and take your virtual CD image in the form of an ISO image and insert it into your virtual machine, and then you put a network card in and plug in the virtual network cable and a graphics card and a sound card and anything else. No, that's mostly it. And then you power up the machine, which is done in this case with KVM or with a VirtualBox. And then the machine starts up, and what does the user do? He looks at the screen and sees, okay, here happens this, and now it does this, and at some point the user presses a key, and KVM has a nice interface where you can input keys, where you just say send key, Control Alt Del, and the machine, the virtual machine will get this key press and do something, and then you can capture the screenshot of the current image the user would see and react on it. So that's a basic principle. There are some more ways we can interact with the VM, but that's what we do. So we let's have a look how it looks in real life. We have prepared something here. Bit out of screen. Yeah, we have some makefile where we say, okay, we make a video of this certain name, which looks for ISO image with the same name in a different directory, and when we do it, it starts running the test code somewhere down there, and fires up the VirtualBox VM on this very powerful Intel Atom processor, and it takes some time to really start up, and finally you see it coming here and can watch it. And the nice thing is, because we capture all the screenshots in the background and write them to hard disk, we can also display them in a web interface remotely. So we can go here to our localhost web interface, which lists the existing old results. And once we reload it, and it reloads, build, and it's localhost. Ah. Oh. Yeah. And there we see that there's a test running, and we can click on it, and can see how it types characters into the VM and watch it live over the web browser, which is a nice thing. And at certain points, the test software looks for certain screen parts and waits until it sees that the system is booted, and then continues with further scripts. And of course, we also didn't only want to do it for OpenSUSE, but did it for a number of different operating systems. And this is structured in a nice way. Where we have a directory for every distribution that contains the actual test code, and there's a part for the installer where it does the certain steps, like the user configuration on Debian looks like this, where it waits until the screen is not changing for 12 seconds, and then takes a screenshot so that you can see later in the overview how it looked at this point, and then it sends a password twice, followed by a return, and then the real name of the user, and another return, and the user password. And when you have a finished test, you can see this nice overview page where you see how it went. We get all the screenshots of the stages. You see, okay, here it booted up, had a nice splash screen, and booted further up, and at some point it ran applications like Firefox, and you can click here to get the big version of the picture and see the details of what it did. Oh yeah. Of course, there's more than just graphics which you could test. So we added some audio tests, which works by playing a certain WAV file in the VM and capturing the output, which you could hear at this place. But this certain test failed, which is why there is a red border around it. But we have the reference audio in here too. You can also see the test code on the web interface, which is also a nice feed. And here's the test WAV, and it contains DTMF, like so we can check automatically if this certain audio came out of the VM by capturing it from the virtual sound card. There are also some tests that use OCR to check for results, like the OpenOffice test here, where the image looks like this. It just types hello world into the program, and then does OCR on this region. And here's the actual output, which has a green border because it matched. And it has something like hello in there. So we assume that it sort of worked. but the more general way of checking results is using reference images. For example, yeah, let's take the Banshee one, where there's just the program started, and usually you see the reference images below here, but since this is local instance, we don't have them on here.
So you usually have when you have a reference image, we may create one.
Yeah.
So let's assume we don't have a reference image. We do a test run and we have our screenshots.
Yeah.
We look at the screenshots and we see, is it did the test fail? Did the test succeed? And we mark the section of the screenshot. We say is it a good or a bad result. And then a reference image is created. Well, in this case, it is not created because we didn't set the CHMOD rights, but it would be created. And then at the next test run, the reference image is searched in the screenshot. It can appear in any place. So that, for example, when you use different window managers, you don't depend on the window opening position. You can find it anywhere. Additionally, we are doing a thresholding so that different, for example, different XTerm background colors don't require us to create multiple screenshots, multiple reference images for the same test. So we only need once ideally.
Yeah. Of course, we have this online instance on OpenQA OpenSUSE.org, somewhere here, where we have a huge number of tests running all the time, like 2 per hour. And we run it for OpenSUSE mostly, for Factory, but we also do it sometimes for Debian testing or Debian SID. And you can see here the results, which look quite promising, with mostly okay results. And one failed. We don't have internet right now. And we also run Fedora sometimes, but only Fedora 16 for now. But this could be extended easily. So any questions so far? It's not really standardized, but there's a sort of a log file created. You can also download through the web interface, and in the log file, it's sort of machine readable, but not standardized, unfortunately. Let's see here. And it's quite useful for debugging because you see which steps it takes and which character it inputs into the VM, and at the bottom you see the results it analyzed out of the tests. That says, okay, this SSH step was marked okay because it saw a certain check.
So these columns are, for example, for reference images. These columns are for audio tests, and there are some other columns here. This is for OCR.
So there was a question over there.
Yeah, I was just wondering, maybe I missed, you guys, do you have a special version of the QEMU, or is it as
the question was if it's a special version of QEMU, but no, it's the very native KVM in this case, and it has a minus monitor option, and you can specify a network TCP socket, which I do when starting the VM, and then my Perl scripts connect to this socket and input line-based commands like send key something or screen dump this file name. And VirtualBox has another interface using vbox manage something. And I map the QEMU commands into vbox manage commands. Okay, so yeah, about the test format, we were thinking of using a different format like the Linaro guys that had the Lava automation. They're using a JSON format to have the test reports, but we didn't get to this point yet.
So here you can see some some videos of the different distributions. So currently we can test SUSE, Fedora, Arch Linux. What else? Debian,
FreeBSD,
Open Indiana.
Yeah.
Open India, I don't
Yeah,
know.
and of course our SUSE Linux Enterprise server.
Yeah.
So we cut here some sequences from various test runs we did in the past together to have an overview. The web interface has some more nice features, like what did we have?
Yeah. We have done some experiments with mouse-based tests. This is a bit tricky because you can't usually set the absolute position of the mouse in QEMU. You have to emulate a touch screen, and you have to do some QEMU patch because on every click the mouse points at 0, 0, and this is not good. But when the patch is applied and the virtual machine, the tested system has this mouse driver, then we can do a mouse-based test. The web interface has some feature for that. So when we are in this running overview where we can see the live test status, there's a cut button like for the reference images. You can also specify an image area, and then you specify a click point. And what's now done is the image area is searched in a screenshot, and then the relative coordinates for the mouse click point are calculated and clicked like you specified. You can specify all kinds of clicks, double click, only mouse down or mouse up, or what you like to do.
Yeah, I remember some nice things we have. For example, we have this nice overview page, and it can not only be sorted but also filtered with all the screenshots. So you get a really quick overview what worked and what didn't. And we can run multiple tests in parallel because every test run writes into its current working directory. And you can just have a number of parallel working directories and do some magic to just do make -J4 to run 4 of them in parallel. But it needs some fast I/O, so we used one SSD in our server. And we had some Irkbot to notify us about new results, but it was quite spammy, so we dropped it for now. But we added distributions. We have this reference images and OCR. We have this audio with DTMF. We even have audio from for VirtualBox, which was a bit more difficult because VirtualBox does not have feature to capture audio, but it can output to pulse audio, and pulse audio can capture. So I wrote some nice small wrapper script that does this part. We have the live viewer with the test process, and you even see in the left part of the live viewer, which we had here. They see the steps that are executed and see an overview of which steps have been done so far and where it is right now. And currently we see that it is waiting for reboot of the VM, possibly. And so you get some nice feedback of what the test does, and not just the results after everything is done. So you can develop even better with it. And one thing is was always bad in the first days, in the early days, where I ran a test and saw an error, and then people asked me, "Oh, can I have your log files?" And I said, "No, the image was already overwritten because the next test ran and deleted everything to have a clean start." So I made an image backlog where the last 20-something tests are kept. And because it's nice to have fully installed working images from operating systems, you can just download them as an gzip file and run them yourself on your local machine with KVM, which also comes handy. And we also found that you can just throw them in your local private cloud and have them as images there and just fire them up sometimes when you need a VM of a very recent operating system. And because getting logs from such an image is still a bit hard because there's a partition table and you need to mount -o loop, comma offset something, and so something needs to be calculated. I exported the log files from within the VM during the test by doing some curl upload magic. So you can now just download the var log content from the web interface, which comes handy for reporting bugs. And because KVM only emulates a certain kind of disk controller, network controller, graphics controller, you always had bugs that were caused by the KVM way of doing things. So I added VirtualBox, which emulates a different network controller and a different graphics controller. So if a bug occurs on both KVM and VirtualBox, it's much more likely to be a real bug that will also affect physical hardware. So that makes it much nicer to have multiple backends. And because we now have this infrastructure for multiple backends, we could also add further modules for testing over VNC, real physical hardware, or using some USB keyboard emulator and an HDMI capture card, which is available for 200 euros something, and could really test physical hardware, even non-Intel ones. So that's also a nice thing to have. Yeah, and of course it's still a bit difficult to create test modules. So we thought about creating a web-based one where you just click, okay, I want to wait for this, and then press these keys, and some way to do. Yeah, I think.
Yeah. Any questions? Yes?
Yeah.
So the question was if we are only using interactive install. Yes.
So far, but of course we could also test automated install, but the main point was to simulate the experience a normal user would have by inserting the CD. In some places we do test automated things like superdub, where it just installs everything, upgrades everything package. Yes, you could test automated installs like OTS or Kickstarter, something. Because it's easier even because you don't have to care for the user input and just wait until it's done, and then see if it really produces something usable.
Yeah. Some more questions? Yes.
I didn't get the question. If we can skip to the later point. Yeah. Yeah, partially. There's support for starting with an already installed system, and the booting part needs only maybe 20 seconds. So you could, in principle, just have your known good operating system and start on it and install the latest version of your application you're interested in, and then run the application tests on top of it. But the main point of the framework is to test operating systems from the bottom up with bootloader and installer and something.
How do you go about creating a test case? You know, the input that you
Yeah.
Can you record that from or how do you do that?
Yeah. So the question is how to create a test case, and it's mostly done manually. Where you have these PM files, which are plain Perl modules, and if you say, okay, I want now a new test, something on Debian, you go here and usually copy one that is similar. You see here that most are symlinks to others. So you just copy this and replace the actions you do. There is osautoins.org site that has a short tutorial on which functions are available, additionally to the normal Perl ones. And using this, it's not too hard to create modules.
I was thinking about, would it be possible to pause during the workflow for demo purposes?
That's exactly what we want to implement when we are in Nürnberg again. The backend feature is already on our development machine, and the front end, I think we will do it next week. And before currently when we want to create a test, we create a plain text test module, and we have a function wait serial, and we put it in. It waits for a special string on the serial interface, and we put a timeout for 1 hour. And then we log in. We can log in into the virtual machine using VNC. And then we just press the keys and write our test module, and then we have it. Then we send the command to the serial line, and it should work.
Yeah, and of course you can also use a stop signal to pause the Perl part and continue it later when you're done playing with the VM.
But the idea would be that during the test case, at some point, you stop the execution of the test case itself, but you can still log into the
Yeah.
VM.
This is the thing we want to implement. So the other thing, when you run the tests in a shell like this case, you can just push Control Z and you pause it. But the other thing, in the backend, it's already implemented, and we just have to get it in the front end. So we will very likely add just a button in this running overview in the web interface, just a pause sign and a play sign to pause only the backend but not the VM. Okay. Yes.
I think the basic install part I did in half a day, and the other half day I spent on Fedora. Yeah.
More questions?
And you saw most of the X11 tests were just symlinks to the OpenSUSE ones, so that's even easier, the part.
Is there a way to assign people to specific tests so you can automatically report problems to the recording review?
No, not at the moment.
The question was about reporting facilities, and those are indeed missing and on the to-do list, but there's not need some more like user management and logins, and it's difficult and maybe not the right thing to put everything into this one place.
The only thing we have is some really basic stuff dependent on the tested distribution. For example, for Arch Linux, we don't use it at the moment, but there is already a script to report. They have a reporting system when you can say this development build failed, this development build succeeded, and it can report if the build failed. But not on the package, but not for each package. So yeah, this is not implemented yet. Some more questions?
So, yeah. Okay, so question was if we know of other users, but so far we know of our two installations, one public and one private, and the Arch Linux guys also ran a version of it once before the machine crashed. Yeah, but in principle others could, they don't need to tell us. Of course, all GPL and public repositories on Gitorious, and it's all the resources are linked on the osautoinst.org website. Okay, so any more questions?
Creating a library for automating interactions between virtual machines. So, for example, I have a project use like packages, basic screenshots, all the backends that support like
Yeah.
and visual box for each other.
Yeah, it sort of is a library, not very separate, but you could just pull the Perl modules and use them separately in a different project, and use this, the macros to input strings and take screenshots, and the automation and the translation layer to VirtualBox and such. Okay.
More
No
questions?
No? Then, thanks for your attention. Okay.